Our own Milky Way galaxy is so big that even traveling at the speed of light, which is 300,000 kilometers every second, it would take many thousands of years to get out of it and look at it from the outside. But fortunately, even close to our own galaxy, there are other large spirals, M83 in the south, M101 here in the north, which give us a sense of how it might look from the outside. And so we're in spirals, the stars are in the disk or in the center, along with all the gas and dust. There's globular clusters often sit out of the disk, but we think it's this elusive dark matter which makes up most of the mass of these galaxies. These are big galaxies, in all cases in spirals. Here we now continue our kind of journey through our local part of our universe. So we go beyond the Milky Way, out to nearby galaxies. We tend to find spirals and their satellites relatively isolated. There are other types of galaxy, and they tend to live often in more crowded parts of our universe, called clusters of galaxies. So all the points of light here, they're not stars, but they're all galaxies, all very relatively close to our own home. And as we zoom in on our nearest big cluster of galaxies in the Virgo constellation, there are something like 100 big galaxies in there, and right at the center is what we call a giant elliptical galaxy. And this is the kind of appearance that we expect the Milky Way and Andromeda to have after they come together in a few billion years' time. So this is the future appearance of our own Milky Way after that merger. So there are spirals, which are big, ellipticals, which can be big and small. There are also odd-shaped galaxies, and we just group them together and call them irregular. And so irregular galaxies, again, tend to be fairly small. Some ellipticals and some irregulars are really small, not much bigger than a star cluster. And so here we have images of a dwarf galaxy. So there are 3 different types of galaxies. There are some galaxies which are doing unusual things. This one has had a recent encounter with another galaxy and is causing a giant burst of star formation right in the center of M82. We have other examples of galaxies right in the process of merging. This is the antennae. The 2 yellow bits are the cores of those galaxies coming together, which the Milky Way and Andromeda will do in the future. We have other examples of galaxies with these huge, beautiful tails. This is a tadpole, and that tail extends hundreds of thousands of light years. So our Milky Way's giant black hole is right now dormant. But there's some galaxies where the big black hole is feeding on gas and stars and dust and gas. And when it does that, it can produce these jets, which again extend for many 100,000 light years. And these are called active galaxies. So some galaxies are formed in groups, others are in clusters. This is another rich cluster called Fornax, 60 million light years away. As we go further out, you get even richer clusters. This is called a coma cluster, but with a total mass of 1,000 million solar masses. Again, mostly this dark matter. If we look even further, this is Pandora's cluster. The big bright things are massive galaxies nearby, but the whole cluster acts as a lens, and the blue things there are very much more distant galaxies which have been brightened by this foreground lens. And here we have a visualization based on, again, real information on the distribution of galaxies beyond our immediate neighborhood. So here all these points are galaxies, galaxy groups, galaxy clusters, and you can sort of make out structure. There are regions where they're very concentrated together, and other regions where there's like a void. They're almost strung along beads along a string. So, in the final chapter, we'll be looking to the future.